Yes, so very good morning to everyone and welcome you in this another session of Grace PS 2025. So our eminent speaker is already joined the session. So before he is going to start his lecture, I want to introduce him. So Dr. Amrish Mishra sir is an accomplished academic and researcher in the field of electrical engineering at the National Institute of Technology, Patna, NIT Patna. Dr. Misra obtained his BE in Electrical Engineering in 2007 from Uttar Pradesh Technical University, Lucknow. Subsequently, he earned his MTech in Power Electronics and Drive. He went on to complete his PhD at the Indian Institute of Technology, Roorkee in 2015. He is currently working as an assistant professor in the Department of Electrical Engineering in NIT Patna, focusing his research on power electronics, converter topologies, and control methods for modern electrical systems. Through his contribution, Dr. Misra has published in reputed journals and conferences and has built a presence in the scientific community with his profile and scholarly work accessible on Google Scholar. As a dedicated educator and researcher, Dr. Misra is committed to mentoring students, driving collaborative research, and fostering innovation in his domain. We are honored to have him among us today, and I'm confident his insights will enrich this FDP. So thank you, sir, for giving your valuable time and joining us. So, sir, can you start, sir?
Is my slide is visible to everyone?
Yes, sir. Your slide is visible, sir.
Okay. Okay. So thank you for inviting me here for the lecture in the FDP and the uh, uh, research area basically related with the control system and power system. So good morning to everyone. First of all, as already I have been introduced that my research area is power electronics, but you might be aware that power electronics itself, it has nothing. If you are developing some equipment at your house and if there is no application for that, then there is no meaning of the development. So any development or research requires some application. So similarly, the power electronics research is basically in the field of applied engineering where it will be applied somewhere. So today my title will be roaming around the role of the power electronics in modern era. Modern era, I mean that how the power electronics is making the electrical world more smart. One by one, we will see few of the example, then you will be able to realize how power electronics is playing the important role. Even though you might be looking around the things and but may not be recognized and actually this is happening due to power electronics. So first of all, we will discuss bit basics about the power electronic system. Then what is the need for the power electronics, why it was required, then application, then converter. I will not introduce much because this FDP belongs to the power system and control area. So, but in power system also, how the converter will be playing the important role. Then we will also go into some details of the HVDC transmission because that is the transmission is the major part of the power system. So that we will see. And as the time permits, we will see some of the more things. So, okay, first we will see where is the power electronics research is helping the research in or and the industry. Power electron first, if you start from any side, first we will start from the left right side, renewable energy integration. Everyone doing research in the power system area, they might be already aware that how the whole world and the government of India also they are focusing on the increase in the amount of the renewable energy power generation. so that our dependency on the fossil fuel that will be reduced. But developing the power by the renewable energy, it is not generation of the power is not difficult. If you install a solar panel, power will be generated to you. But point is that power easily possible to use it directly? Answer will be no, because your solar panel will give the DC voltage, and that DC voltage may not be with the appropriate voltage level so that you can use with any of your appliances in the house. So just generating the power by solar panel is not sufficient. Not only solar, it is by wind also. Wind-based power generation, basically they are generating the power by the variable frequency, because wind is a natural phenomena, so speed cannot be controlled by the human. So it is a natural phenomena. So as the wind speed changes, the generation frequency, amount of the voltage, all those things are changes. So if the voltage and frequency is continuously changing, as a user, you cannot use that power. So power is available, but you cannot use it because it is not with the appropriate value or appropriate rating. Second application is the heating and lighting control. Induction heating, microwave heating. Nowadays, in the heating area, you can visit any of the steel plant. You will be very easily able to realize that how in the heating, how power electronics is playing role. Coming to the lightning, one small application. Uh, Most of us, we have seen the yellow color incandescent bulb. That 100-watt bulb, it was coming in 10-15 rupees around 2005. So that bulb was 100-watt, and everyone might have seen the light intensity of that one. But after that, the CFL came into market, and after the CFL, there was the LED bulb came into market. And after LED bulb, nowadays the lights are available where you can control the intensity of the bulb, or where you can control the on off using mobile application, using Bluetooth and all that. So all that is happening only due to the advancement in the power electronics. Because the technology changes, the size of the items they are getting reduced, and you are able to add the more features. That is not possible in the 100-watt old bulb, because there was no control available. But here power electronics will provide the control on each and everything. That part we will discuss. Then coming to the energy conservation, again different form of energy is available. All the forms cannot be used by you directly. So as per the requirement, the power can be utilized in other forms if required. Then next is the power electronics in the transportation system. If you see the example of either electric vehicle or the Indian Railway or the metro system, everywhere, if you are having interest, you can go and check into the detail that they are not directly feeding by the transformer. There inside you will find the different kind of converter, different kind of static regulator. They will be able to change the voltage and frequency. Then power electronics in the power system as the area of this FDP also. Power electronics in power system means if you are designing any converter, if you talk about compensation, if you talk about any of the fact devices, they are basically helping the system to be in the controllable. If any voltage variation is there, current variation is there, any compensation is required, any type of instability problem, all those things can be handled only by the use of power electronics based system. Then converter itself, AC DC converter, DC to AC converter, they are basically the major area of the power electronics. Then electric drives and control. If you talk specifically, even though this talk will not be more focusing on the drives, but if you see the example, if you go any of the industries or any of the transportation system, either it is a Indian Railway or your any of the vehicle or the metro system, everyone is example of the electric drives. Means you are controlling a motor with the help of the power electronics in the appropriate manner. Appropriate manner means things should be more precise. If you see the metro, at the metro station, train is stopping at particular time. So stopping at particular time means there must be a precise control. Similarly will be in the vehicle also. If you are having some random vehicle where no control is there, and it will be difficult for the driver to manage the acceleration and brake at the appropriate time. So this is the just we discussed about the major areas where it is playing the role. Now coming to the next slide, here we will see what are the, you can say, combination that is used along with the power electronics. Means power electronics, you might be only understanding the rectifier and inverter. That is not the exact case. Power electronics is used with the, if you start from the top side, computer aided design and simulation. So if you are doing some simulation on the computer, means MATLAB or any of the software, so that simulation part will showing you only the virtual output. But if you want to implement those things in the hardware based system, there are the certain system available. OpenRT is there, DSpace is there, RTDS is there. Many of the modern things are available where you can utilize that computer based design or computer based simulation can be directly used with the power electronics based converters. Means how to generate the firing pulses for the converter, how to measure the actual voltage and current from the power circuit and feedback to your simulation, process it appropriately, and again generate the new modified pulses for the converter for the new reference value or new parameter values. Then the power semiconductor devices. Power semiconductor devices is the major key component, you can say, for the basically the heart of the power electronic system. And many of you will be already aware about the semiconductor, but just a one line definition I will try to add it from my side, even though it's not new to anyone. Semiconductor is something between conductor and insulator. So as the name suggests, so it does not mean that its conductivity lies between conductor and insulator. Semiconductor is the middle point. Left one side you will find the conductor, another side you will find the insulator. But conductivity, it has nothing to do with the conductivity. For the insulator, conductivity is 0. For the conductor, conductivity is very high. But semiconductor is not something the related to the conductivity. It is something related to the any device can be used as the conductor or can be used as the insulator as per the user requirement. If I want the same switch to work as the conductor, I will give the command appropriately. If I want to use the same device as an insulator, then I will do with the only command values, and a single device can be controlled either as a conductor or as an insulator as per the requirements. Then third one is the converter circuit. Converter circuit will be basically different form of everyone using the UPS and different type of power supply or AC to DC conversion. All that kind of conversion is basically the simple converter circuit. Then electrical machine, again if you are talking about the induction machine, because that is the most viable used machine nowadays. Previously there was the DC machine, but nowadays induction machine is most popular machine, three-phase induction motor. So three-phase induction motor, if you want to control, you must use an inverter. Because if you are using with the auto transformer, only you will be able to change the voltage. But speed control method also require the change of the frequency, and at the grid frequency is always constant. So you must use an inverter that can be able to change the frequency so that machine speed, torque and everything can be controlled. Then power system we have already discussed. There are the many applications. It is used along with the power system. Then artificial intelligence, we will discuss some of the example today only. That power electronics, it is also making use of the fuzzy logic, neural network and all the artificial intelligence techniques for the performance improvement of the system. Then coming to the control, even though control is a separate area you are thinking about, but power electronics itself is a part of control. That controlling the electrical energy, we will see with the examples. Then DSP, FPG and all the application specific ICs. So they are also, these are the things that are used along with the power electronics based system as per the analog and digital IC. ICs will be required for the appropriate operation. If you want the regulator, then regulator IC will be required. Some places you want the isolation, then isolation IC will be required. So all those things together make a form that is useful for the any application. Now, as you can see on the screen, this is one of the exploration rover that normally sent to the other planets for the research purpose. If you see with the very example, it is a very small kind of electric vehicle. It is having the motors in the vehicle for roaming around, for capturing the data and all. And on the top side of it, you can see one of the camera. Camera is for recording the pictures and analyzing by the image processing and all. That is for the research purpose. But as a designer of this one, what the data captured by this will be done, that will be analyzed by the someone else. That may not be our research area. That may be by soil, by atmosphere, by anything. But what we are interested here, being the electrical engineer, is that how this vehicle will be designed and how it will be operating. It is a vehicle, but it is not only used for the movement. That's why I'm not calling it as a vehicle. It is a kind of vehicle where you are having the motors for the motion in all the directions and you are having the camera. But remember, it is not connected through the wired supply. So it is having the solar panel or some kind of lithium battery to feed the electrical power to all the equipment for operation. So the solar power is available, the power is stored in the battery, and after that the motor will be used in the wheels for the motion. Again a motor will be used in the camera handle for the rotation in all the four directions. So if you are using the motors at two places, both the motors rating will not be same. What I mean to basically say, you are using a motor in the wheel also for the motion. You are using a motor in the camera handle also, so that camera can rotate in as per the desired direction. So both the motors are not same. Some motor may be higher rating, some motor is the camera rotation is the small job. So it is a small motor can be used. So both these motors require the different level of the power supply. So now the role of power electronics will come into picture, that this motor may be suppose taking 1.5 ampere current, another motor is taking the 2 ampere current. So we have to, being a power electronics engineer or being the electrical engineer, we have to design a supply such that it can provide the appropriate supply to all the component in the system. Similar to your desktop and laptop, all the things connected, they are not requiring the same level of supply. So for that, there is a SMPS provided as per the requirement of every component of the body parts. They provide the appropriate supply. Similarly, the Mars orbiter mission, similar kind of thing you can relate it here also, that there are the many components in the whole system. So they are taking the power by the solar panel, power is stored in the battery. Then from that battery, appropriate converters will be used at the places so that motion is required, capturing data is required, storing the data, all that part. Then if you are capturing and storing the data, you must be having some processor also. So that processor also requires the supply. And power requirement of a motor and power requirement of a processor is not same. So you have to properly take care of the what kind of supply is required and what you are providing. Third interesting example is the robotic arm that is normally used in the International Space Station for the repair of the any equipment if require replacement or repairing. So here also you can see the multiple axis you can find. So at every places you want a motion control. I'll not exactly call it as the drive. Motion is there, but in the ideal term in the electrical engineering, because motion control also involved in the robotics. So robotic is also example of a drive, but motion control involves the precise control. That motion control in direction, motion control in terms of speed, motion control in terms of vertical, horizontal, or like that. So motion control here, appropriate control will be required. Motor will be used or some other kind of actuator for the motion. Those things that has to be properly taken care by the appropriate rating. Now coming to our visual world here, that all these things are not new to anyone, everyone has seen. All these are basically the, again, you can say examples how the power electronics is doing the things in the better way. Power electronics means making in the starting only I told that it will make the things smart and efficient and all that example that we have already aware. So everywhere you will find a PCB. If you are having the speed control in the mixer and all, now we will use the static regulator, or you can say the solid state based regulator. They will not have any kind of losses. Here, coming to the one most 24-hour used equipment in our house, that is the fan regulator. Everyone is aware about the old fan regulator, that is with the big size and with the knob is provided. Now modern regulator, they are in the small in size. Both the regulator, they are doing the same job. It is only used to control the speed of the fan. As the weather condition changes, you want to increase or decrease the speed of the fan. So old regulator, they are only based on the resistance based regulator. But now they are using the solid state devices. Solid state devices, again I told, the semiconductor devices. So what is the advantage? Previously old regulator, they were, if you are using for continuously 10-12 hours, you can touch and feel the heating on the regulator. Why there is a heating? Because you are using the external resistance so that it can reduce the voltage appearing to the fan. So by you are decreasing the speed by inserting the external resistance in the circuit. So basically you are wasting the power somewhere else when you require the less power. So you are doing the job by wasting the power somewhere else. But nowadays modern fan regulator, they are basically solid state based devices. They are doing the things by some other way without any loss. Remember this thing, that is the important, that we will discuss with example also, that I am saying that modern regulator, they are with the very less loss or the ideally zero loss. Why? Because of the property of the semiconductor devices, either it will work as the conductor or it will work as the insulator. So in ideal condition, losses will be zero and size is also reduced. So size is reduced, efficiency is increased, and the rest of the things we will see. Now some application of example I told about the artificial intelligence also. You can now easily find out the fuzzy logic based washing machine. Pre-programmed things will be fitted there and you will find the application. Now coming to the most promising application of nowadays, that is the electric vehicle. It will be charge a battery in the car. Battery is fully charged. Now once the battery is charged and as a driver you are sitting in the car, you can be realize what kind, if you are a car driver or if you know the car, then you will again realize similar to the rover we have seen the example. Here also there is a multi-function things are required. If it is an electric vehicle, there will be a motor for the driving of the wheel. There must be a motor for the window glass to come and down. There will be the indicator control, light control, all the things will be there. So, but all those things will not be requiring the same power supply. So just charging the battery and start the vehicle and go, it is not possible. You have to use the multiple kind of things. So for that, you require the specific power supply for each component in that sense. And another thing, that if you are driving the car and you must be aware that if your car is running at constant speed and load is constant, then it will take the constant voltage and current. If If you are increasing or decreasing the speed, then your controller must be capable to provide the low and high current as per the requirement. Coming to the another major application of the power electronics is the electric traction. Electric traction, everyone might have been traveled in the trains. So here the electric engine, if you are finding, they are basically taking the single phase power supply and based on the conversion and all. Previously, there was the DC motors used in the train for the driving purpose, because DC series motor was having the high value of the starting torque. But nowadays, all those motors are being replaced by the induction motors, because induction motor itself having many of the advantages. If you see about the three-phase induction motor, it is one of the most versatile motor. Nowadays, induction motor is also getting replaced in certain application by the help of the BLDC and other modern PMSM motors, because of the high efficiency only. But induction motor is preferable only due to the very low maintenance cost. DC motor, there was a problem with the carbon brushes, commutators, so a regular interval maintenance is required. So maintenance was the major problem with the DC motor. So the technological, we moved to the induction motors. But here, getting the single phase supply and feeding a three-phase induction motor, it required definitely a conversion types. Single phase supply will be converted, and then with the help of the converters, it will be converted to three-phase. How it is converted, that also we will see with. Now coming to the wind energy system, as we discussed, the wind is a natural phenomena. So as the wind speed changes, it will change the speed of the rotation of the generator, and generator speed is changing means the generated voltage frequency is changing. So as a user, if your frequency is changing, you cannot use the power at home. If you want, you can go into more detail of the situation of the grid fail or the blackout. It is related with the frequency only. Your frequency variation from 50 Hz, if it is above and below the 5 Hz situation, then power using will be difficult, even though supply is available. But if your frequency suddenly whole system changes to 60 Hz, then your most of the system in the power system and control area, they will be stopped working. So variable frequency, then to make them consistent, constant voltage and constant frequency, you need the wind energy conversion system, so that a AC voltage will be first converted to DC, and from DC with the help of inverter, it will be given to the appropriate value of voltage and frequency. Again, there are the certain examples as you can see on the slides. In everywhere, there will be the use of power electronics. What I mean to say, it was just about the introduction, that what are the different area where the power electronics is playing the important role. Here again, if you talk about the different kind of energy sources, then these energy sources again directly they cannot be combined. For combining all these things, you need a different kind of converter so that power can be used appropriately. Then another major application of the power electronics that we will discuss in today's lecture also, that AC transmission, you are aware, transmission is because it is from the longer distance. So what are the certain problems? Being a power system engineer, you must be able to relate about the compensation problem, tower size problem, and in case of any fault, how to deal with that. And this much longer transmission line, there will be the amount of losses, there will be the maintenance of conductor, tower and all. So all these things will be making helpful if you are shifting the whole AC transmission to the DC transmission. And DC transmission will be possible if you are converting your AC power into DC first, because all our power generating stations, either it is a NTPC or NHPC, they are generating the power in the AC form. So transmit, and at the user end also we require the power in the AC form. So AC is generated, AC is being used. Now further transmission purpose, if you are going for DC, then first you have to convert the AC power into DC power, transmit it for the longer distance, then use inverter for the conversion again to the AC power that is required by us. Then these are the certain more application of the artificial intelligence as how that things can be utilized. So these are the certain examples. Now we will take further introduction part is already we have covered that how we will. Now we will see what is there actually inside the power electronics based system. In my opinion, power electronics is basically the control and conversion of electrical power, either AC to DC or changing the voltage or changing the frequency, step up, step down, anything. Means whole as a whole application of the semiconductor devices for control and conversion of electrical power, that is called the power electronics. So control and conversion both. Control means flow control, power flow. If you want the less output, you can reduce it. If you want the more output, you can increase it. Conversion of the power means type of the power can be converted AC to DC, DC to AC as per the requirement and as per the available sources in the application. Now these are the certain definitions given by the different researcher that power electronics deal with the use of electronics for control and conversion of the large amount of electric power. Another important thing I can discuss it here is that power electronics is the name suggests it is a kind of electronics, but why it is not the major part of the electronics engineering. That is the major, if you are the pure electrical researcher or engineer, you will be able to relate that why it is not the major thing in the electronics engineering department. Because it is only using the semiconductor principles and semiconductor devices, but the use of the power level cannot be handled by the electronics engineering. If you are going for the HVDC 500 megawatt transmission, so that megawatt transmission, electronics people they will raise their hand, it is not possible for us. Then that will be only possible by the electrical engineers, where they are aware to use the semiconductor devices at the high power level. And that is why power electronics is the main subject of the pure electrical engineering, not for the electronics engineering. They are doing it for the 5 volt and 12 volt. They might be doing the same thing, clipper, clamper, rectifier circuit and all. But if you ask them to design a, suppose a 200 kilowatt rectifier or inverter, it will be difficult because they are not using that level of power. So we are using the semiconductor devices. Basically, they are the electronics component, but nowadays with the development in the technology, we are having the sufficient rating of the thyristor and IGBT, more than 5000 ampere currents. IGBTs are available. So now second one is the power electronics is the analysis, design, manufacturing, application of the power converter. So these are the different definition. The last definition, if you see given by the Wilson, that is the what I find more interesting, is that power electronics is the technology associated with the different efficient conversion, control and conditioning of electrical power by static means. Now, from its available input form to the desired electrical output form. Now, as a whole, I can say power electronics is something that can provide the available power in the any desired form. If you are using in your house, if you are having a AC supply, but if you are having some equipment, they are operating in DC. So by default, you are purchasing an adapter. So that adapter is itself power electronics. Because if you are having an adapter for your laptop, adapter for your mobile, adapter for your television, adapter for your any of the equipment, if you are talking about the adapter, that adapter itself is the power electronics. But you might be saying it is just the way of the power flow. No, it is not the way of the power flow. It is the control and conversion of electrical power. Again, it will come to the point. So this is the main thing about the power electronics. Again, these are the different area where it is combined, all those things. Here, as I told, I will try to finish the introduction portion, then we'll move to the main power system. So why power electronics means, as I told, the losses will be zero. Why losses is zero in fan regulators? Because these are the semiconductor devices. Either it will be on or it will be off. From the circuit, you can see if the circuit is short circuit, then ideally voltage drop across it will be zero. So whatever the current flowing, power loss across the switch will be zero. Now coming to the open condition, if it is completely open, current through it will be zero. If current is zero, then whatever the voltage it may be facing, total power will be zero. So due to this property, power loss in the semiconductor based devices, they are becoming zero. And that is the phenomena used in the fan regulator. And this is the reason your static fan regulator, they are not getting any heating, even though you turn on it for 24 hours. It will not get any heating. Ideally, losses is zero, but practically you will find some few milliwatt or the microwatt amount of the power loss. These are the some devices they are used in the. These are the some passive element, inductor, capacitor, transformer. These are used as an interconnection system for making the whole system. Now these are the other factors why it is focusing more importance on the power electronics, that improvement in the power semiconductor fabrication. Nowadays it is very easy for us. If I want a three-phase rectifier, instead of going to 6 number of devices, ideally a intelligent power module is available with the 6 devices inbuilt into single box. We need not to open and check anything, just use as a single box, that as a three-phase rectifier. If you try to remember your UG time, at the time of undergraduate, if you are studying the power electronics, you are finding a three-phase rectifier is one of the very big thing. So that means that is big, but due to the development in the technology, the things came to very small in size. Yeah.
तो कल मेरा कैलकुलेटर से यहाँ पे खो गया कल 8:30 से ही क्लासेस से लगा था 5:30 तक
वहाँ सिक्योरिटी गार्ड है नीचे हॉस्टल के पास, उसको बोल दो।
उससे मैंने बोल दिया, उन्होंने कहा 4th फ्लोर तक का शायद गेट खुला हुआ होगा। जो गेट पे से ताला तो नहीं लगा हुआ, पहले गेट्स फिर खुल नहीं
तो उनसे बोलो ना जाके, गेट हम थोड़ी खोलेंगे, सिक्योरिटी को बोलो।
सॉरी सर।
So due to the development in the technology, the intelligent power modules are available. Being a electrical researcher, not only the intelligent power modules, if you want any kind of thing, if you want directly a PWM generator for your design of STATCOM, design of your DVR, you want a PWM signal, that things are also available in the market directly. If you want a specific power supply, that also can be. If you want a specific, for example, 40 volt supply with this much current rating, that is easily available in a single box format. So that all that due to the development in the technology in the field of power electronics, component size of everything that is getting reduced. Second is the decline cost in the semiconductor that is being used. Advancement in the semiconductor fabrication. There is the application specific ICs, that DSP and all that. They are making the things in the, if you are going for the research level, then you will be able to relate these things, how these things are very easy and convenient to use. Now coming to the overall completion of this one, that what area that is being used. Power electronics is mostly useful in the domestic and commercial domestic application we have discussed. In the commercial application, any of the industry, if it is a rolling mill, paper mill and all that, then you will find the different kind of motors. For the motor speed control, definitely the converter will be required. Industrial application, again, if you want the heating, if you want induction heating and all that, then you require the power electronics based control. Telecommunication, transportation, we have seen the example electric vehicle and train and all that. Generation, transmission, distribution, here you may not be able to directly see if your area is not power system, but otherwise at everywhere you have to use the control by the power electronics. Power electronics converter is developed After that, it has no use unless until you apply it somewhere. So either go to the generating station, in the transmission, or at the distribution end. Now smart meter and all that are being used. Power rating started from the less than 1 watt, mean the electronic toys and all. It is used in the megawatt range. One example we will see here, that if you are having a pump, we'll discuss with the losses, that if you are having a pump and water flow is required and motor is being supplied by the power. So if you want the high power output, then your power close the valve to 20 or 30%. Rest of power output, your water output you will get, and rest of the water will be blocked by this valve. But if you are using the power electronic system for the same motor, for the same power pumping application, if your water output level is high, then your losses will be less, because motor speed will be controlled in such a way that it will operate the pump at that speed so that it can provide a certain amount of water only. But if you want to reduce the water output, then if you are having the conventional system, because motor is not aware. What is the basic reason here is that motor is not aware you are opening or closing the valve. If you are using the motor in case of your vehicle, similar thing, and if you are putting the 50% brake, how motor will come to know? Motor will do its job with the full efficiency. It will take the full voltage and current. But if in the open loop system, if you are pressing the brake, what will happen? It is not aware that car is running at full speed or it is running at half speed. So there will be power loss. If you are taking the 50% power, then 50% power will go into loss. But at the same place, if you are using a power electronics based system, then you can control that motor so that it will give you the appropriate voltage and current to run at the 50% speed only. Now these are the different power electronic devices. In the lower power range and high frequency range, MOSFETs are being used. This is just I'm telling you for the awareness point, that GTO and thyristor, they are being used in the high power application. Either it is a electric locomotive or the transmission or the generation and all. So that level, high power level, thyristor, GTO are being used. Lower level MOSFET but MOSFET is suitable for the high frequency operation like SMPS and all. Now these are the basic type of converter that you are already aware. So this converter type means whatever the form of power available to you, same can be used by appropriate converter, whatever is your output power requirement. Now power electronics part is over. If anybody having any doubt, then we can discuss. Otherwise, I'll move to this one. Anyone, if you want to ask anything, you can ask. Otherwise, we'll move further and we'll have the discussion later on. Okay, so we'll move. So this is a three-phase system. It is not new. Everyone is aware at this, being a faculty, that three-phase phase voltage and line voltage. Power electronics is playing very important role in power electronics is playing one of the very important role in if you are using a three-phase convert, because if you talk about the power system, then mostly your things will be in the three-phase. Either you are transmission side if you are controlling anything, or if you are generation side doing anything in the electrical, then it will be dealing with the three-phase. So in three-phase, there is a one thing that you can have, that sequence of the volt in the phase voltages, they are 3, but line voltages you will find 6. So 6 line voltages, you can see that there is a specific sequence for that. RYB, you cannot write any random RYYB, YR, YB, YC, YR like that. So there is a specific sequence for that purpose, that you need to understand. If you go for the line voltages, then if you see from the left to right, if you write the R, Y and B, then first line voltage will be coming from the origin point will be start from R, move towards right, or you can say move in the clockwise direction. Clockwise direction, move in the clockwise direction only. So first voltage will be RY. I'm talking about the line voltage. First voltage will be RY. Then again start from R. Second voltage will be RB. So first voltage is RY. Second voltage will be RB. Third voltage start from Y now. So third voltage will be YB. Then fourth voltage will be again start from Y and R. So first YB will come, then YR. Again start from B, BR and BY. So these are the 6 line voltages that will be coming if you are going for the analysis of anything. So this is just a simple output of a 3-phase rectifier. By changing the firing angle value alpha, you are getting the different firing angle alpha is equal to 0, output voltage is maximum. Firing angle alpha is equal to 90 degree, average output voltage is 0. Alpha is equal to 180 degree, output voltage is minimum. Minimum means negative maximum. But till now I have discussed with you the example of the importance or the benefits and all that for power electronic system. But now I will tell you the major disadvantages we are facing or the problems we are facing by the power electronics. Being an engineer or the researcher in this field, we are till now we have discussed all the advantages that is getting STATCOM, DVR and all that design with the help of power electronics. But if you are using a power electronics based system in the power system, it will disturb your power quality. Even though power electronics is being used for the power quality improvement, but I am saying that power electronics converter, they are disturbing the power supply. How you are disturbing the power supply? I am a user at the home. I am using a big size of rectifier. So, but my house will be connected by certain transformer in the colony. So I am taking the power from that transformer and using a rectifier in my house or in my lab or anywhere. So my place will be connected by the transformer somewhere nearby. Now if I am using a rectifier, if I am changing the firing angle, I am changing the input current supply that is taken out from the secondary winding of the transformer. So I'm taking the current from the supply voltage. As a user, I am not able to disturb because supply voltage is a thing that will be given by the supply system, means electricity board. But voltage I am not able to disturb. But by using the power electronics rectifier, I am disturbing the current drawn by the transformer. Because I am connected by a transformer, my neighbor is also connected to the same transformer. So if I will draw the non-linear current or non-sinusoidal current or any current that is out of phase with the voltage, it means I am disturbing the power factor. If I am taking the current that is in phase with the voltage, then I am not disturbing the power factor. That is why while we are discussing the detailed analysis of any of the converter, one of the voltage, RMS value, all that comes to analysis. But what is the most interesting part I feel is the input power factor. Why it is the important part? Because it is something like that I am doing the mistake and my neighbor is going to suffer. So it is that I am going to do mistake means if I am using the rectifier at firing angle value 90 degree, then power factor is getting deteriorated. And power factor is getting deteriorated at the input side of converter. Input side of converter means connected to the secondary winding of the transformer. So from the same point, my neighbor is also connected. So my neighbor is not getting the good power factor. They are getting voltage and current out of phase. So what will happen? For them, it will be a problem. So that is why in some of the country, there is a penalty, and penalty is for either disturbing the power factor or injecting the harmonics. So harmonics also is playing the important role. If you are used, even though again and again I am saying, even though power electronics converter are used to remove the harmonics, your STATCOM and other component are there, they are using for removal of the harmonics. But as a system in the power electronics as a rectifier, if you are connected by the AC source, you are injecting the harmonics in the system. So in certain countries, there are the system and the smart meter itself, it is available that how much harmonics I am injecting to the system. What I am doing in my house, that is the kind of independence I can do. But my independence is not that I can disturb the supply system. So I am using a converter that for our, if I am not disturbing any neighbor, any of the nearby transformer, then nobody can claim us. But what I am not free to use anything that is disturbing the power quality of the power supply of my neighbor or the whole supply system. So by using a simple rectifier at the different value of the firing angle, here you can find the angle between voltage and current, and this angle between voltage and current, it will lead to the power factor. So this way it is disturbing. So advantage is also there, but use of the power electronics, what is the major problem? That it disturbs the supply system. How to solve the problem, that also we will see. Now coming to the another interested topic we discussed at the time of starting, that if you are having the three-phase AC supply, why unnecessarily will go again for this kind of thing? As I told example of the induction motor, if you are having a three-phase grid supply available to your lab or available to your house, and if you want to operate an induction motor at the variable speed drive, so that cannot be directly used, because if you are having a three-phase supply, you can change the voltage by auto transformer if you have, but changing the frequency is not easy for you. In the lab, it might be possible, but normally auto transformer or rheostat you can use for some voltage drop and all that. But if you want the variable frequency, then you must use this system. This is a on the front side, there is a rectifier. It will convert the grid supply into DC. There is a DC link. Then there is an inverter. What is the advantage of this? This is not new to all the electrical engineer. But here the advantage, first thing is that I am able to control the voltage and frequency both at the output end. That can be any requirement. Another important thing, any small fluctuation on the input side, that will not disturb my output, because I am having the DC link. And DC link, based on the fluctuation level requirement, you can use the capacitor size. If capacitor size is sufficient, then any small fluctuation in the input voltage will not be disturbing my output voltage of the three-phase requirement, that is variable voltage, variable frequency. So this was the kind of detailed introduction to the power electronics system and its all application specific areas. Now coming to the one of the promising application of the power electronics is that HVDC transmission. In HVDC transmission, first we will see what was the requirement. What is the requirement of DC transmission unnecessarily? Because generation of the power is in the AC form, transmission of the power is done in AC form, and distribution is also done in AC, because as a user, I need to use the power in AC form. Why I need to use in AC form? Because all the appliances in my house, either it is a tube light, fan, air conditioner, refrigerator, all those things are standard and they are suitable for used with the AC supply. Suddenly I can go take the fridge and connect it to the DC, they will not work, because system is designed for the AC use only. Now, what is the problem and in what circumstances there was a requirement of DC transmission. So first reason was bulk power transmission to the longer distance. Even you will say that already it is a transmission system is made, but being the researchers in the power system area, if the transmission line distance is long, you must be taking care of compensation. So compensation has to be done at the regular interval. If the transmission line is very long, then you can find some line losses, because if it is a double circuit line, then you will find the 6 number of conductors. So 6 conductor length, inductor, capacitor, resistance of the line, all those will take a large amount of power loss. Power loss is the one case. Second case is the infrastructure. That much infrastructure is required. Now, underwater transmission. Underwater transmission means, suppose one country like Singapore, they are all 4-way surrounded by the seawater, but they are not having any of the power generating station. How they will take the electricity? So normally what they can do, they can purchase the power from the neighboring country. So they can purchase the power. But if it is a land border, then just by the conductor and tower, power can be given. But in case of underwater transmission, being a power system expert, you can think of how compensation will be done. Being an expert in the power system area, you must be able to helpless that if an underwater means cable can be laid down, and but how the compensation will be done if anything is required. So that is the one requirement. In case of underwater transmission, AC transmission got difficulty. These are the reasons I am discussing why to go for DC transmission. Clear? So in case of underwater transmission, your compensation and all that part, that will be difficult. So it will be go for the DC transmission. Third major reason is interconnecting of the two AC system with the different frequency. So interconnection of the two AC system is, for example, if your neighboring country is using another frequency, you are using another frequency. So how to sell and purchase of the power? So sale and purchase of the power will be done, because these two countries, they are operating at the different frequency, so they cannot be connected by the AC system. So in that case, there will be a requirement of interconnection of the two AC system. Then it is possible only through the DC transmission. Here, you are all, because all of you are faculty, so you must be understand that if I'm talking that AC power is generated in the AC form, first convert them into the DC form, then that DC power will be transmitted for a longer distance, and again a station will be installed, an inverter station, so that it will convert the power into DC AC back, and that can be again distributed by the state electricity board. So state electricity board, and another important thing, it will be, everyone will be aware that in our country, generation, transmission and distribution, these are the three independent parts. A single company is not handling all these things. Generation part, the NTPC, NHPC, they are the independent organization. Their job is to do generation only. NTPC will generate the power, but remember, it will give to someone, and after the generation, NTPC is not responsible for anything. Then transmission in our country is taken care by the Power Grid Corporation of India. So Power Grid is taking care of the whole transmission system. So NTPC generating the power, they are not giving power to Power Grid. They are selling the power to Power Grid. That NTPC has generated the power, they have sold all the power to the Power Grid. Means now Power Grid has purchased the power from NTPC. Now it will take care of all the transmission things, and after the transmission, it has to go to the distribution end. At the distribution end, your distribution authorities can be anything. It can be state government, it can be Indian Railway directly, or it can be any big size user. They are directly taking power from the power grid. So, but based on their requirement, state electricity board is already there. They will make you, and they are purchasing power from power grid. So whole three systems, they are totally different. So distribution and a state electricity board is there. They are purchasing the power from the power grid, and based on their own convenience, they are distributing the power to the user. And as they have purchased the power from the power grid, so they are charging from the customers for the use of electricity. So just understand, there are the three independent things. They are operating together. So going for the DC transmission, you require one rectifier station at the input end. Then you require another rectifier station at the output end, so that AC power is generated, converted to DC, and again transmitted, and again converted to AC form by help of the inverter. So here it is a comparison, so that you can see the AC transmission initial cost is low. But if you are increased x-axis, there is a distance, y-axis, there is a cost. So as you increase the distance of the transmission, the cost of the AC transmission is more as compared to DC transmission. But at the lower distance, your AC transmission cost is less. How? All the three things, they are divided in basically three parts. First is the terminal equipment cost. Terminal equipment cost means, in the case of AC, your terminal equipment cost is less, because you need only transformer and all. So transformer is already the part of the system, but you don't relay, circuit breaker, all that. Those are the small parts. But and second cost in the AC transmission will be line cost. Line cost means transmission line, number of conductor, tower and all. So line cost and terminal equipment cost, these I'm not including the operating and running cost. That is basically included, but I'm discussing with you the initial cost. Why at the lower distance they are operational cost? If you are going for the longer distance, operational cost will be the different issue. But equipment cost means terminal equipment you are using. Line cost means number of conductor and tower you are using. So that is less in AC if distance is less, because that these are the conventional things that is being used since a long time. But if you are going for the DC transmission, its terminal equipment cost is very high. Why very high? As I told, it will be require a rectifier station. So rectifier station is not the rectifier you are looking in the lab. It is some generates of the thousands of the, suppose 400 megawatt power. So 200, 400 megawatt power rectifier, single rectifier size will be size of a building. Their rating of the devices, rating of the conductor, all those things, that will be the different level. So here conversion of AC to DC is not of what we are looking to the lab level. So in introduction of a rectifier and an inverter in the system is basically the terminal cost. So that will increase. So initial cost of the DC transmission is very high. Initial cost you can also say as the capital cost. That will be very high. But the line cost in the DC is very less. Why very less? In case of AC, you require the 3 conductor or 6 conductor as per the requirement. But if you are going for the DC side, number of conductor will be required. Less number of conductor will be required. 2 conductor is used for the plus and minus. And in certain cases, there is the things available where a single conductor can be used for the transmission and ground will be used as the return path, what is basically done by the Indian Railway. So in case of the DC transmission, it is also possible to use the single wire transmission, and ground path can be used as the return path. So overall, if you see, and how it is increasing with the distance, at the lower distance, your compensation requirement will be very less. And if the distance is very high, there is a breakdown point, and this is called the break-even distance. And this break-even distance is normally the value of 500 kilometer. 500 kilometer, if the transmission is to be done less than that, then it is good to use the AC transmission. If the transmission distance requirement is more than 500 kilometer, then it is better to go for the DC transmission because cost of the transmission will be low. Cost of the transmission will be low, but one thing you can say that your already system is the DC AC system. So changing of the infrastructure, it will cost something more. But at the end, once you install the line, you will find your running cost will be also reduced in the DC transmission because your compensation requirement, your conductor is less. So all that infrastructure cost as well as the running cost, that will be reduced if your distance is more than 500 kilometer. Here, for the example, you see the two type of the transmission lines. First one is the 400 kV AC line. Second one is the 500 kV DC line. So this is about the tower size, the area it is taking, and because if you are the agricultural land and the open area, then space may not be a problem. But if the same thing is passing through the urban area, then space will be a issue at certain cases. So if you are going for the DC transmission side, your size of all that will be reduced. This is the development with the technology, with the time, how we move for the DC transmission voltage level. Now we are above the 1500 kV voltage is already achieved. Now coming to the main heart of the HVDC transmission. What is the disadvantage of the DC transmission? I have told you the many cases of the advantage, that tower size will be less, transmission cost will be less and all that. But similarly, I discussed some problems with the semiconductor devices. Here also you will find certain disadvantages of the DC transmission. I am not discussing the advantage first. First I am discussing the disadvantage. So first disadvantage is that difficulty in breaking the DC current. As compared to AC breaker, DC breaker cost is more. That you will find because you are already in the area of the power system. So you will be try to find out the cost of the, suppose same rating 500 ampere or the 1000 ampere, AC breaker cost and DC breaker cost. So DC breaker cost will be high. So that is the one problem. If you are going for the transmission, definitely you will be bound to use the kind of the DC breakers. Second point, inability to use the transformer to change the voltage level. So transformer is, in my opinion, transformer is the main hero of the whole electrical system. Why it is the main hero? It is playing the main role at every place. If you ask me that who is the main hero of any substation, I will say transformer. Why I will say the transformer? Because transformer is the main hero. Because if you see the nameplate of a substation, if you go to either transmission substation or the distribution substation, normally it is written that it is a 132 kV / 33 kV substation. That's it. That is the nameplate of a substation. I'm not going inside the substation. If you stand on the gate of a substation, see the name board, it will be direct any value rating, but it will be written as 132 kV / 33 kV substation. That's it. So that's it means the purpose of this substation or all the component together is to change the voltage level. So what about the all other equipment, relay, circuit breaker, CT, PT and all that? All that are the auxiliary component. Whenever transformer is there, circuit breaker, transformer is the main hero of the whole substation. All of them are the supporting actors. Supporting actors means in case of any fault, CT will detect the current, it will give the signal to relay, relay will give the command to breaker, so that open the line. But main job of the substation or main job defined by the power system of a substation, that is being done by the transformer. Now, our second disadvantage is that inability to use the transformer to change the voltage level. And transformer, I have given too many the highlights of the transformer, but it is one of the very simple electrical thing that is easily changing the voltage level. It is normally taught in the 11th, 12th and your BTech first year level, that transformer can change the voltage just by using the number of primary and secondary turns. So for changing the voltage level in a transformer, it is not a complex system. It is one of the easiest system. If you are going for the high voltage rating transformer, then your cooling and other requirement will be along together. But as a operation of the transformer, this student started teaching in the 8-9 classes. What is uh, mutual induction? And based on the mutual induction, this is the only principle used. So operation is one of the simplest, but job is biggest. So DC transmission, and what is the good thing about the transformer? At any point of time, you can install a transformer and change the voltage level. At any point in the whole transmission to distribution end, at any place you can use a transformer and change the voltage level as required. Like you see the Indian Railway, they are using its own 25 kV power supply. If you are aware about it, then it is very good. Otherwise, you try to find out the reason. If 33 kV supply is already available in our power grid and the state electricity board network, why railway is using 25 kV? So that is the kind of assignment if you don't know the answer. That what is the specific reason that Indian Railway is using 25 kV. So transformer is easily able to change the voltage level anytime. But if you are having in the DC transmission, in the DC voltage, changing the voltage level is not an easy task. That is the one major problem you will find, that if a 12-volt battery cannot be easily converted to 50, for that separate DC converter is required, and that is not an easy task. But changing the voltage level by the help of transformer, it is one of the easiest job in the whole transmission network. Third disadvantage of the DC transmission will be high cost of the converter equipment. Definitely, if you are using the rectifier station, converter station, in the rectifier station, you are having the if it is a 6 pulse converter, then 6 firing circuit, that much control circuit. So that all will be increasing the cost of the converter. Generation of harmonics needs AC and DC filter. This is the thing that I told at the time of disadvantage of the rectifier, the introduction of the power electronics, that if you are using any of the semiconductor based devices system, you will introduce the harmonics. But for that harmonics, a filter will be required. Complexity of the control. Complexity of the control definitely will be there. Now, right now you are looking that many component in the power station. If you are going for a HVDC substation, you will find more number of component, because other than circuit breaker relay and all, you will find firing circuit, current control circuit and all that. So they are basically increasing the complexity. Here in case of the conventional AC substation, you are not finding anything to continuously control. But in case of the DC, if you are suddenly finding that there is increase or decrease in the harmonics, if you want to change the power level, all those things that can be done. And another important thing, if you remember in the advantages of the power electronics I told, here it will be very important to insert that point. The definition of the power electronics came with the control and conversion of the power. control word is important. Why control word is important? Because in case of the AC transmission, being the power system researcher, you try to think if your load demand, if some certain load is connected to the secondary winding of the transformer, if it demand the power, is there any option in the transformer to limit that demand? No, nothing. If the secondary winding of the transformer demand more current, transformer will demand it from the primary side. Primary current will be high. Means if secondary winding demands more current, definitely through the transformer, it will demand it from the primary side. Means inside the transformer, there is nothing like the flow control. If the demand requirement will be less, it will draw the less current from the primary winding. If the load is increases, it will demand the more current from the primary. If it is not able to supply, then there is a possibility of the burnout of the winding. But if you are going for the DC transmission, that control part of the power electronics will come into picture. You might have studied the rectifier and inverter and all in detail, that I am not discussing. So in the rectifier circuit, it is possible to control the power flow. That is not, since you might be aware about that grid fail situation and all. Means as a user, I am connecting any charger or any equipment to the socket. What is basically done? I am start drawing the current from the socket. My socket is connected to my meter and my meter is connected to the transformer in my colony. So it will draw the current from the secondary winding. I am just connecting any equipment in my socket. What are the things happening? I will draw the current from the secondary winding of the transformer. That will draw the current from its primary winding, and the primary winding will be drawing the current from the substation. Substation will draw more current from the power grid or the transmission line. Transmission line will draw the more current from generating station. At the end, load goes into generators. Because AC power is not possible to store. So if AC power it is not possible to store, means what is actually happening? I am connecting a socket and I am taking the power from the NTPC directly, I can say. Because transformer is a component, as I told, if you are connecting anything on the secondary, definitely it has nothing to do. It is just playing the role of a guide standing on the gate. Go this side like that. If secondary winding demands more current, it will ask the primary winding to supply more current. That's it. That is the job of the transformer. Some beauty is there, but this is a limitation. If there is nothing like a power flow control in the transformer. So transformer, if you are going for the DC side, it is possible because you are able to control the output voltage, output current by change in the firing angle. So transformer is one of the good thing. It is doing its job, but it is not having any kind of power flow inside the transformer. Separately, you can use anything, any kind of relay or anything that the power level is going below this, disconnect it. So complexity of the control is another problem. Now, all these disadvantages can be overcome very easily, except point number 2, that I will discuss later. Except point number 2 means, again, there is no such easy method that can easily change the voltage level in DC. So that part I will leave to you for the future research, you can say. That except point number 2, rest of the things can be easily sorted it out. So recent development in the DC breaker technology, with the development in the technology, DC breaker cost is also getting reduced. So this is the recent development. Second one is the modular construction of the thyristor valve to increase the valve rating. Modular structure means if you are bothered about the rating and all, instead of using a big system together, use the modular structure. Suppose there is a 6 pulse converter. So one option is that you take a very single piece of the 6 pulse converter. If any fault, you have to replace the whole system. But instead of that, use the 6 modular different structure. if there is any kind of short circuit in any of your thyristor valve, then you change that particular valve. Means modular structure means if there is any fault in any part of the system, you will find that it can be easily replaceable. So modular construction is available for each and every component. Now 12 pulse, 18 pulse and 24 pulse converter. Pulse number is what normal 3-phase rectifier you are looking. That is basically the 6 pulse converter. You are using the 6 number of devices. And it is not called the 6 pulse converter because of the 6 number of devices. It is called 6 pulse converter because output of a 3-phase rectifier is coming in the form of 6 pulses. One pulse duration is 60%. Total a period of 360 degree. At alpha is equal to 0 degree, you are getting a 6 pulses in the output. A single phase half wave rectifier is a 1 pulse converter. But remember, not due to the 1 pulse converter, due to the one number of devices. Again, I am saying it is a 1 pulse converter because it is a 1 pulse in the output of in a complete cycle of 360 degree. Coming to the example of a single phase bridge rectifier, it is using the 4 number. That is why I to discuss this thing specifically. Single phase bridge rectifier is having the 4 number of devices, but it is used as the 2 pulse converter. Why 2 pulse converter? Because a single phase rectifier output is positive half cycle, negative half cycle. But number of devices is 4. So it is not a 4 pulse converter. It is a 2 pulse converter because you are getting the 2 pulses in a cycle in the output side. Output side you are getting 1 pulse, 2 pulse. So single phase bridge rectifier is a 2 pulse converter. Your 3-phase half wave rectifier is a 3 pulse converter. 6 pulse converter is using 6 devices. That is the coincidence, I can say. But 6 pulse converter is not called 6 pulse because of 6 number of devices. Further 12 pulse converter is using the 12 number of devices. But that is not the exact reason. 12 pulse converter we will see in a cycle of in a complete cycle of output voltage, it is having the 12 pulses. And each pulse duration will be 30 degree for a complete cycle of 360 degree. So if you are increasing the pulse number of the converter, what you will find that your power quality is getting increased. Harmonics will be reduced, voltage level will be good. And last one is the use of digital electronics. Nowadays, modern digital electronics is there. A person will be sitting in a AC room having on the computer. All the things can be easily monitored and be controlled also by the mouse that can be easily controlled. These are the some of the examples that data I have got from the Power Grid website. These are the some installed DC system in the country. Now, coming to the converter station, what are the things that are being used? Your first AC source is there, second AC source is there. In between, you are having a 2 station. One is the converter 1, converter 2, you can say, because all the time you cannot say converter 1, converter 2. All the time you cannot say rectifier inverter, because the power flow direction is this converter will be working as rectifier, this converter will be working as inverter. But if power flow direction changes, this converter will be working as rectifier, this converter will be working as inverter. So you can call it converter 1, converter 2. So based on their requirement, they will be changing its operation by changing value of the firing angle. So the major component is the converter, transformer, then valve. Valve means the devices, either thyristor or IGBT or that. They are called as valves. Then in the AC side, you will use the AC filter. In the DC side, you will use the DC filter. Why? Because just now I have told, if you are using a power electronics based system, harmonics will be generated to the system. So that harmonic should not affect our main system. For that purpose, filters will be required at both the ends, DC side also, AC side also. That will be required. This is a view of a, you can see it clearly. This is a view of a HVDC substation. AC station, you are already aware what kind of appearance is there. Then after that, if you are including the DC, then first you will have the converter transformer, then you will have the valve hall. Means either it is a 12 pulse converter, 16, 18 pulse converter. Based on that or based on the requirement, you will find it. Then after that, the DC switch yard will be there, because DC breaker has to be used and all that protection point, it will be used at the end, and after that DC line will be going out. These are the certain devices, diode, your IGBT, GTO and thyristor. They were mostly used for the, anybody saying anything? Okay, no. So these are the devices with high power rating available. You can easily check on the internet what are the highest rating available of the devices. So high power rectifier, this is a 6 pulse rectifier. Why I told 6 pulse? Then 12 pulse, 18 and 24 pulse. Multi-pulse, what is the purpose? I told na 6, 1 pulse, 2 pulse, 4, 6 pulse. All these, if you are increasing the pulse number, definitely your complexity is going to increase. But why we are going? We are going because it is reducing the harmonics. It is reducing the harmonics means, if you see the output of a single phase bridge rectifier, 2 pulse output, this is it anywhere looking like a DC? No. It is called the pulse DC or the pulsating DC. It is not DC. Output of rectifier is not a DC one. It is a pulsating DC. So that cannot be done. For that you have to use a regulator, filter and all. Then you will be able to make it as a DC supply. So purpose of going for the multi-pulse converter is that to reduce the total harmonic distortion, to improve the input power factor. As I told, we have discussed the 3-phase rectifier. If you are changing the firing angle value, you are disturbing the power factor. Not only for you, you are disturbing for your neighbors. To avoid semiconductor devices in series. Yes, here multi-pulse converter will be used and it will be having its certain advantages. We will see one by one. 6 pulse converter we have already seen. THD level observed will be 32% in the current. If you are going for the 12 pulse converter, it is used with the star delta and star zigzag transformer. Phase shifting transformer will be used for making the pulse 2 converter operating at the angle difference of 30 degree. So 12 pulse converter is basically a 2/6 pulse converter connected in series with a phase difference of 30 degree. That's all. So these are the 2 pulse. This is the 1/6 pulse converter. This is another 6 pulse converter connected together by the phase shifting transformer. These two are getting the input voltage with the 30 degree phase difference and output will be combined together. So you will get the output. One will be connected in star, another one is connected in delta, and output is combined and you will get the output. This is the output of a 12 pulse rectifier. Input current, output current, and primary line current is coming out to be 8.38%. And it is also used for the reduction of the lower order harmonics. And lower order harmonics are dominant in the nature. So if you are with the, because filter design for the lower harmonics, it is very difficult. For the higher order harmonics, any LC filter can be designed for the higher value, because higher order harmonics are having the low magnitude. The lower order harmonics, they are with the higher order magnitude, high magnitude, and that high magnitude will be difficult by simple filters. So for that, it is included in the converter itself that it will reduce the lower order harmonics by default. Then coming to the 18 pulse converter, first one is zigzag, second one is star, third one is again zigzag. So zigzag transformer will be used. Total output will be 18 pulse. So lowest harmonics present will be 17. Line current TSD in the 12 pulse converter is what, 8%. In the here 18 pulse converter is 3.06%. So you are reducing the line current. This line current, remember again I am talking about the input current. The input power factor part I have discussed that how it is disturbing the power factor. But similarly, I am not drawing a sine wave current. I am drawing non-sinusoidal current. So if I am drawing the non-sinusoidal current, it means I am injecting the harmonics in the system. So by growing the number of the pulse number of the rectifier, if I am injecting the harmonics at the higher level, it is a punishable offense. Actually, if it is not, it should be there. Because if you are using some equipment that is disturbing the power supply system, that is not good for others. So higher pulse number converter, they are injecting lesser harmonics in the transmission, not transmission. To the transformer, you are spreading in whole system. So higher pulse number reducing the total harmonic distortion. 24 pulse rectifier, again you can find as the one is the zigzag, star, zigzag. This is just about the creating the phase difference. First one is creating the minus 15 degree. Second one is 0. Third one is again minus 50. Fourth one is minus 30 degree. So based on combination, remember here 4 converters are used. But remember all 4 converters are independent 6 pulse converters. Independent 6 pulse converter connected in such a way through the phase shifting transformer that it is producing a 24 pulse output. 24 pulse converter is not anything, something new. It is the combination of 6 pulse converter, 4 number of 6 pulse converter connected by the help of the phase shifting transformer with the appropriate phase shift provided, and then output will be combined together to get the output in the 24 pulse, and you can see the line current TSD is 1.49%. So I can here we can discuss something, then we will try to wind up there because there will be the time required for the question and all. So in the renewable energy, solar, wind and all the things they are being used. These are the examples, few examples of the renewable energy sources. PV is already we are aware, wind energy, biomass, geothermal. Geothermal is basically the energy of the earth that is being utilized for the generation of the power. This OTEC is the ocean thermal energy conversion, means if you go into detail, you will find there is a difference in the temperature of the seawater in the top and in the deep. In the deep and in the top, there is a temperature difference of the water in the seawater. So that temperature difference is utilized for the generation of the power. That is the basic concept of ocean thermal energy conversion. Here I am not talking about the tidal because it is a different case that is, but here ocean thermal is different than the tidal. Ocean thermal energy conversion means water surface temperature is different, water depth water temperature is different by using a heat exchanger in between. But these things are very costly actually. So, but some places it is being used. If you want, you can go into detail and search how the ocean, but name is the ocean thermal energy conversion. The temperature gradient of the seawater is utilized for the generation of the power. Here again, coming back to the role of the power electronics in the renewable energy, everywhere the power electronics will be required, because again, at every stage you want the control and conversion. You are using the solar photovoltaic, then you are generating the DC power that to be given to the grid, it has to be converted to AC. And that AC with the appropriate frequency, appropriate voltage, so that will be done by converters. And if you are having an intelligent control system in between, that will be high power density, easy controllable, reliable. And if you are having the control system in between, you can have some kind of online monitoring, some Wi-Fi, Bluetooth based system, so that data can be displayed at some other location also. That is possible. The wind energy, we have already seen that it is a natural phenomena. It is clean energy, no doubt, but natural phenomena as the wind speed changes, and as the wind speed changes, its output frequency is changing. Now, one of the major thing coming to my mind right now is that wind is something that cannot be installed everywhere. As far as the NTPC plant, there is no dependency on anything. Only blank space will be required. If coal is available, NTPC plant can be operated. Similarly, going for the hydropower plant requirement is that water must be available. So if water is available, hydropower plant can be done. Coming to the wind, it is important because if the wind is available, but it is not good, you will not find this kind of thing mostly in the seashore or the hills area. But there is a question in my mind that if the wind is available here in the city, can we install the wind turbines? Is it possible for anyone to answer that if wind is available? Question is that if the wind is available, can we install the wind turbine here in our area? No, because not only it is killing the birds and all, that is the different case. I am going to the technical aspect. If you are installing in the civilized area, it will be difficult because bird killing and it will create some obstruction and all. But more than that, wind turbines, they are creating the noise. That noise, it will be difficult if you are installed in the civilization area. It will be disturbing the people all the time and it will be difficult to stay. So that is the one of the major problem with the wind turbine. As far as the solar panel, there are the multiple kind of example. Either it can be solar roof mounted or it can be the wall mounted. These are the three, right? There are many more, but we have considered three major suppliers in the country. But more interesting fact, the total power capacity of the renewable energy in the 2019, it was 85 gigawatt. In 2022, it was 175. And see, renewable energy requirement in the starting itself, I told that to reduce the dependency on the fossil fuel, it is better to go for the renewable energy based power generation. It is a kind of situation of, you can say, Atmanirbhar Bharat or anything like that, because self-sustainable means if you are depending on fossil fuel, if it is available with you, then okay. Otherwise, you have to import and all. But if you are totally trying to be focused on the renewable energy based sources, then you can be Atmanirbhar in that sense. So the electricity consumption is growing. So the consumption is projected by the 15,280 terawatt hour in the by 2040. Renewable energy will be account of 55% of the total installed capacity by the 2000. These are the government data, what the government is planning and projecting. Another important fact, I'll give you that in India was the 5th largest installed capacity of the renewable energy, 4th largest installed capacity in the wind in the power, and 5th largest installed capacity of the solar power. This one is the foreign direct investment, that if you are suddenly increasing the renewable energy, but renewable energy is the new system for us, not for us, for everyone. So renewable energy means, suppose you talk about the solar based power generation. So solar based power generation you cannot do at home at randomly. You need the solar panels. So if you need the solar panel, panel manufacturer has to be come into market. So that solar panel and your that kind of things, if you are increasing the demand for the renewable energy power, then for this FDI data is provided that $8.1 billion is provided from, it is increased. This much $1 billion data has been, means money has been coming as the foreign direct investment. Now this is the sum structure you are already aware for the grid connected system. In the daytime, you are generating the power and using that, but store some power in the battery. And in the night time, if you can use the same power. But in the daytime, if you are generating the surplus power, that power can be given to the grid. Another thing I'll give you, this slide I just put specifically for the each energy storage is specifically required. Being a power system engineer, what is coming to your mind? And here another thing coming to my mind is the inertia of the system. That is it possible to go completely on the renewable energy? Answer will be no. Because if your total power is based on the solar panel, then there will be the stability problem. Suddenly any fluctuation will affect the whole system. So inertia has to be there. Inertia of the power system, there is a word. Inertia of the, even though power system is nothing, it is not like a single equipment. Power system means whole infrastructure together. So inertia of the power system means that any small disturbance, it is not going to affect me. So that inertia is coming due to the big size generators. So if you are moving to whole renewable energy power generation, then you will face problem in the stability point of view. So inertia has to be maintained. So that is why it is not possible to go 100% on the renewable energy. For a small portion of the area that can be done, but in the very large area where fluctuation is possible, multiple kind of load, for a single building it is possible, for a single area it is possible, but as a whole it will be difficult. Similar to the inertia, there is another thing, that is the storage. Is exactly energy storage is required. So if you are going for renewable energy also, suppose you are totally based on the solar panels and suddenly due to the bad weather condition, you are finding some sunlight is not sufficient available, then what you will do if you don't have storage? So storage is also an important part. Based on the power requirement, storage requirement will change. This is some typical data provided for the small microgrid. So this is the sum option provided by the Tata Solar for the domestic application. Depending on your house size, area available at you, then what kind of connection you can take. If you are having the 200 to 300 square feet, then there is a solution of the 2 kVA. What are the things provided? This data is taken from the Tata Solar Power. What kind of things they are providing on grid and off grid system. So thanks from my side. If there is any question to anyone, then I'll be happy to discuss that.
Yes, so any questions from the participant sides? If you are having any questions or doubt, you may please ask. You can unmute and you can ask. So I think, sir, no one is having doubts. So thank you so much, sir. And I truly appreciate the time and efforts you have taken to share your experience with us. Your contribution has greatly benefited our participants, and we look forward to more such fruitful interaction in the future. Thank you once again, sir, for your inspiring session.
Okay, okay. Okay, thank you, Satsangi, and thank you, Deepak, Neeraj, and Arvind. All of
Ji,
them
thank
are
you,
my
sir.
friend. So
Yes, sir.
very much thank you will not be required. But anyway, it was a nice time spending here with the participant and all. Okay, thank
Yeah,
you.
thank you, sir. So
Okay.
participants, you may please join at 11 a.m. and the session will start. So thank
So
you.
should I leave now?
Yeah, you can leave, sir.
Okay, okay. Thank you, thank you.
So I'm closing the meetings. So we will start at 11 a.m. Thank you.